Here we see a wave plotted with displacement on the vertical axis and distance on the horizontal axis, showing key features like the peak, trough, amplitude, and wavelength. The peak is the highest point on the wave, while the trough is the lowest. Amplitude measures how far the wave moves from its equilibrium or resting position. This is the wave's maximum displacement and is an important way to gauge the wave's energy. Wavelength is the shortest distance between 2 points in phase, usually measured peak to peak, and it tells us how long one complete wave cycle is in space. Both amplitude and wavelength are typically measured in meters, even though the graph here uses centimeters for illustration. Understanding these properties helps us describe and analyze waves in a clear, visual way.
Here we see how the position of one point on the wave changes over time. The period, labeled as t, is the time it takes for one complete oscillation or cycle of the wave at that point. We measure this in seconds. Frequency, on the other hand, tells us how many of those complete cycles happen each second, measured in hertz. It's important to remember that period and frequency have an inverse relationship, which means if the period is longer, the frequency is lower, and vice versa. This relationship is simply expressed as frequency equals 1 divided by the period, or f equals 1 over t. Understanding this helps us describe how waves behave as they move through time.
Wave speed is all about how fast the wave transfers energy, and this speed is determined solely by the medium it moves through. Whether the wave is in air, water, or any other substance, the properties of that medium dictate the wave speed. Importantly, changes in the wave's amplitude or frequency don't affect how fast the wave travels. You can see this illustrated here, where the wave changes as it moves into a different part of the medium, but the speed depends only on the medium's characteristics, not on those wave features. The wave equation shows how wave speed, frequency, and wavelength are connected. It tells us that the speed of a wave is equal to the frequency multiplied by the wavelength. Frequency measures how many wave cycles pass a point each second, while wavelength is the distance between repeating points on the wave. So if the frequency goes up, but the wavelength stays the same, the wave moves faster. Likewise, if the wavelength changes but the frequency remains constant, the speed adjusts accordingly. This equation ties together space, time, and speed, helping us understand how waves travel through different mediums.